We're asked to find the zeros of each function, and if any of the functions do not have zeros, we enter DNE. A zero of a function is an input that makes the function output 0. So for example, if f of c equals 0, then c is a zero of the function. If we look at the graph of a function, and the point c comma 0 is an x-intercept or horizontal intercept, then c is a real zero of the function. So because we have functions of x, to find the real zeros, we'll set each function value equal to 0 and solve for x. So the first given function is r of x equals -1 minus 5x. So to find the 0 or zeros of this function, we set r of x equal to 0 and solve for x. So we'd have the equation 0 equals -1 minus 5x. To solve for x, we first isolate the variable term. Let's go ahead and add 1 to both sides of the equation. So we'd have 1 equals -5x. And then to solve for x, we divide both sides by -5, which gives us -1/5 equals, the right side simplifies to just x, which means the zero of the function r of x is x equals -1/5. The next function is q of x equals 5/2 x minus 40. So to find the 0 or zeros, we set q of x equal to 0, which gives us the equation 0 equals 5/2 x minus 40. Now to solve the equation, the first step is to isolate the variable term by adding 40 to both sides. That gives us 40 equals 5/2 x, and then -40 plus 40 is 0. And now to solve for x, we multiply or divide. Instead of dividing both sides by 5/2, let's multiply both sides by the reciprocal of 5/2, and therefore we'll multiply both sides by 2/5. So on the left side of the equation, let's write 40 as a fraction with a denominator of 1. Now before multiplying, we'll simplify. 5 and 40 share a common factor of 5. There's 1 5 and 5, and 8 5s and 40. So now the left side is just 2 times 8, which is 16. On the right side, 2/5 times 5/2 is equal to 1, because these are reciprocals. 1 times x is x, and therefore the 0 of q of x is x equals 16. Next function is g of x equals -2x minus 2. To find the 0 or zeros, we set g of x equal to 0 and solve for x. To isolate the variable term, we'll add 2 to both sides. Simplifying, we have 2 equals -2x, and -2 plus 2 is 0. And finally, to solve for x here, we divide both sides by -2. 2 divided by -2 is -1, and on the right side, this simplifies to 1x, which is just x. So the 0 of g of x is x equals -1. Next, we have the constant function n of x equals 13. If n of x equals 13, again, to find the 0 of any function, we set the function value equal to 0. So here we set n of x equal to 0, and we get the equation 0 equals 13. And notice how there's no solution to this equation. 0 does not equal 13. So this tells us the function n of x has no zeros. And from our homework, we're told to enter DNE. Now this should make sense, because remember, if we were to graph this function, it would be a horizontal line crossing the vertical axis at 13, something like this. And notice how it does not cross the horizontal or x-axis, and therefore there are no inputs, where the output would be 0. In this case, all outputs are always 13 and never 0. In the last function, we have s of x equals 17 minus 3/4 x. So we'll set s of x equal to 0 and solve for x. For this equation, Instead of subtracting 17 on both sides of the equation, let's add 3/4 x to both sides. We can do this because we have a 0 on the left side of the equation, and it will isolate the variable term. Simplifying, we have 3/4 x equals, this would be 0, so we have 3/4 x equals 17. Now to solve for x, instead of dividing both sides by 3/4, let's multiply both sides by the reciprocal of 3/4, which would be 4/3. So simplifying on the left side, the product of two reciprocals is always 1. 1 times x is x, so we have x equals. On the right side, let's write 17 as a fraction with the denominator of 1. Notice here nothing simplifies, and therefore we multiply the numerators and denominators. 4 times 17 equals 68, and 3 times 1 is equal to 3. So the 0 of s of x is x equals 68/3. I hope you found this helpful.